So 10, 11, and 12 are our last ones. We actually use the same method to simplify as we did for 7, 8, and 9. It's just that our numerators look different. There's 2 terms in the numerator, so we're going to have to multiply out. And that's all. So I'll do number 10 and then leave you guys for 11 and 12. And again, use number 10, watch number 10 as you're doing 11 and 12, pausing as necessary. So we have 2 terms over 2 terms. This is not simplified because it has a square root here in the denominator. So just like 7, 8, and 9, we should multiply by the conjugate of the denominator. Remember the conjugate, you change the sign in the middle, 4 plus root 3 over 4 plus root 3. And now we just have a good bit of multiplying to do. Root 2 times 4, so that's 4 root 2. Next, root 2 times root 3, those are both square roots, so that's root 6. Now we do root 5 times 4, which is 4 root 5, and root 5 times 3, which is root 15. So we multiplied all those out. We have 4 terms, and actually none of them are alike to be able to add. In the denominator, we learned our short way of doing this before. We can take the first number squared, so that's 16, minus the second number squared, so that's 3. So root 3 squared ends up being 3. And so actually I'm going to go ahead and write that. Square root of 3 squared is 3. And now we can have our simplified answer. So 4 root 2 plus root 6 plus 4 root 5 plus root 15 all over 16 minus 3 is 13. And again, as mentioned in the last video, we would look at coefficients to see if we can have a common term to reduce, and we don't. This is 13 in the denominator, so there's no factors in 13 except 13, which just definitely doesn't go into 4. So that is our simplified answer there. And you can use that same method to do numbers 11 and 12.